Hello, what's up YouTube? Welcome back to another episode of I Make Free Energy for you guys on YouTube. Today I have to really apologize with everyone, all my subscribers. I didn't make any free energy generator as seen on YouTube. Yeah. Today rather gonna introduce this video with fact. Yes, the Large Hadron Collider CERN. Yeah, it takes about 600 gigawatt to operate. Oh yes, that's about half of the total amount of power the whole CERN consumes in 1 year. Yes, that's quite a lot. Yes, so if you're actually wondering where all the energy and power come from, yes, well, France still relies on nuclear, yes. So one of the substations is actually fully dedicated for CERN and all the experiments, yeah, so we can create antimatter. Yeah, that's beautiful, guys. So no, there is no free energy. Nobel Prize of CERN, they don't make free energy generators, no. How about NASA? Remember the International Space Stations? Yes, if you're actually wondering where all the energy comes from to actually power all the devices, instrumentation, solar panel, yes, they rely on solar panels, yes, they're actually quite efficient, about 22% up there in space, so definitely much better than here on Earth, slightly better I would say. And it's also kind of cool that everything just started with a simple vacuum tube, just like this one. And we end up creating antimatter. That it's amazing. But today we're actually not going to talk about research and so on. We're actually going to, this is a video reply of a comment. This comment comes from a YouTube channel with this guy tried to make free energy out of, like, you know, a simple washing machine motor and a simple controller. Yes, a knockoff eBay Chinese controller. It's a simple DC AC controller for brushless motors. Yes, this guy is making free energy out of these things. But this is not like a personal video, to be honest with you. Everybody can do pretty much whatever they want and incredibly fail. But the comment says, skeptical open mind is shitting his pants by watching this video. I tell you one thing, skeptical open mind is laughing his pants off by watching that video. Yeah, someone tried to make free energy out of Toys R Us components and Mickey Mouse knowledge, yes. However, today we're going to actually reserve the whole video by debunking about 12 myths about free energy and physics in general. So let's stay tuned. So, let me tell you guys a good way to get brainwashed. First of all, stop having a formal education, and then eventually turn on YouTube and start watching a bunch of conspiracy videos made from con artists that are non-qualified pseudoscientists with a bunch of random nonsense theory, never backed up from any, of course, a mathematical explanation, neither rational explanation, and of course, a bunch of promises such as, you know, we make a free energy generator, I'm not going to patent it. It's going to be for free for everyone to enjoy. And they keep such a goodwill talking. In reality, they never deliver anything, of course. It's all about making money. Please make a donation for a non-profit organization. They keep blaming, like, oil companies, government, you know, power companies, you get ripped off, yeah, blah, blah, bunch of blah, blah, blah. In reality, these people will never deliver anything. After so many videos of, you know, conspiracy, no one ever delivers anything because, of course, it's just a bunch of bullshit. Let's go take a look at what actually a real informal education does to you. School, first of all, teaches you how to use your brain in the most efficient way. Of course, this is a very positive point that we need to definitely highlight. The second most important point is that what school does to you, all it does to you, school in this case, is actually teaches you what previous scientists have been discovered and or invented. That's all about. If you want it or not, this is the truth, this is the reality of fact. You can't just take one scientist of your choice and make it as a king. You think that he's the only scientist in the world. No, we need to acknowledge what other previous scientists have been discovered through like gazillions of observation and mathematically proven fact and experiments. Not just a bunch of pseudo, nonsense theories. One more time, school teaches you how to use your brain in the most efficient way. Second point, school teaches you what have been previously discovered from other scientists. That's all about. I read somewhere in the comments, someone says, laws. What are the laws? Laws are meant to be broken. And guess what? I totally agree with the person who said that. Laws are meant to be broken. Probably they won't last too long. Probably they won't last forever. There is only one problem with the fundamental laws of physics. In this statement, someone forgets about something. No one so far, and I said no one so far, gave us a mathematical proof, a mathematical evidence that someone broke the fundamental laws of physics so far in centuries of research. So yeah, I'm still open-minded though. So let's clarify this point once for all. Anytime we use the term laws of physics, the laws of physics, in reality it's a misinterpretation of the word equation. When we say laws of physics, most of the laws of physics is actually equation. So at this point, what is an equation? Very simple. An equation is just an equality. This one equal this one. For instance, this one equal this one. An equation is given by a pure observation. This is not an invention. This is just a discovery. We discovered that this one it's equal this one. And it's given by pure observation. This is a natural occurring phenomenon. We can just observe it. This is not an invention, one more time. This is just a discovery. It's pure observation. You want to have a better visualization of it? I'm not good at mathematics, but this is very easy to solve. This one plus this one equal this one. So now we're using numbers, but numbers is just a convenient way for us to actually visualize something. It can be an object, it can be whatever you want. So we call it in this case 3 plus 1 equal 4. So for instance, this one, it's equal this one. And this is just an observation. You can do it physically with apples. Take 3 apples, you add 1, physically add 1, and here you have it. 4 apples. You don't have to use 3, 1, and 4. You can say John, Daniel, and add your own name to it. No problem. It's just numbers are just a convenient way for us to give a name and represent something. This is an equation. This is a matter of fact. If you want it or you don't want it, that's not a problem. This is what it is. Whether you like it or not, an equation is always right. So, what's a law at this point? Let's talk about law. It doesn't really take so many words to describe a law. A law, someone made a law. A law, it's something you must obey to. I will say one more time. A law, it's something you must obey to. This is an equation. This is an observation. If you don't want, you don't agree, you don't have to obey to it. But if you try to build something and you don't observe the equation, trust me, your device will never work. So a patent, it's a good proof of free energy. So someone made some kind of weird device, got a patent on it, and that's a good proof you made a free energy device. No, guys. A patent, it's a good way to invest and make money. Yes, nowadays everyone can get a patent in 3 easy steps, and I will post the link in the description. Wake up! Look around. We are surrounded from energy. We live in an ocean of free energy everywhere. I do agree with you 100%. As a matter of fact, Einstein had a chance to prove that mass equals energy. There is only one little problem with this statement, is that if you want to turn all this energy around us, turn into a usable form of energy, suddenly we have energy loss. And this is the reason why we will never have a perpetual motion machine. Now imagine to make this already impossible machine and extract even more energy out of it. That's what we call like a free energy machine. Does it sound like kind of like a bush? For so many times, guys, I hear this statement. My free energy generator works on a high voltage, high frequency, and no current. And that's why I don't have energy loss. This is the most stupid comment and statement I ever heard in my life. I strongly believe these people don't even know the difference between voltage, current, and frequency. Voltage, amps, and frequency are 3 different measuring units. I will say one more time. Voltage, amps, and frequency are 3 different measuring units, and they are all strictly related to each other. No, you cannot have just, your machine will never work only on voltage. Today we'll see why. I hope, I will try to explain this in a very elementary and basic way with no mathematics, and I hope you enjoy my lecture. So everything starts from a particle, an atom. An atom is made out of electrons, protons, and neutrons. Atoms normally are not electrically charged, which means that they are well balanced. If an atom is not well balanced, well, it will interact with the rest of the atoms around it, creating like a chain reaction. And this normally doesn't really occur in nature. In order to turn this atom into what we call ion, it can be a negative ion or positive ion. We either need to add more electrons or add more protons. Another way to do that is actually to strip the atom of an electrons. Or either way, we can add more electrons. So this atom or particle will turn into a negative ion. Of course, it takes energy to break the structure of an atom. I will say one more time. It takes energy to break or modify the structure of an atom. And this is what we call voltage. Now, if this atom now, this negative ion, is carrying a negative charge, we're creating a potential. What is a potential? It means that this atom is capable now of releasing one of the electrons to the next atom, to the neighbor atom, because it's carrying a potential. I will say it one more time. This negatively charged particle is carrying a potential. That potential is the property of this particle to release an electron. It's going to release it to, of course, the nearest and most available atom that is actually at this point lacking. It lacks of an electron. It wants one. And this is what it is. Now, if we're having a charge, if we're having a voltage or a potential in our conductor, and it stands still right here, nothing will happen. Nothing, absolutely nothing. You need some kinetic energy. As we said before, in order to create or modify a structure of an atom, it takes some energy. It can be any kind of energy. It can be a chemical reaction, it can be a mechanical reaction, it can be some form of friction. Not a problem, it still takes some energy. Once we create this potential, okay, and it stands still into your conductor, it will do absolutely nothing. This particle here needs to travel to the conductor. If this particle does not travel through your conductor, suddenly your machine will never work. Voltage, it needs to travel through a conductor. These particles, they need to go from point A to point B of your conductor. It does not really matter how small is the little conductor. It can be a piece of copper, of metal, or any conductive material. Some of the material are more, let's say, more conductive than others, which means that the bond of the electrons on the particles are looser than an insulating material, of course. It does not exist a perfect insulating material, like otherwise it does not exist a perfect conducting material. There is always some resistance inside, because normally the electrical charge into an atom normally creates a barrier and opposite reaction to the electron flow. That's called what we call a resistance. It's a natural occurrence. You don't make it, you just observe it. No, you cannot eliminate so much. A little bit, there is always some form of resistance. It does not exist a perfect conductor. So now, once this voltage travels from point A to point B, okay, the speed of this charge moving from point A to point B, we call it current. That's what we call current. So now, can you make a machine that only works on voltage? No, you cannot. There is always some current. If you want to use that voltage, we can have a charge without current, of course. But if you want to use that charge, you need to move those electrons from point A to point B of your conductor. That's what we call a current. So can you have a machine that only works on voltage without current? No, it's bullshit. Bullshit, but it makes no sense to begin with. So far we've been talking about voltage and current and blah, blah, blah. So now, if you're wondering, is there any way to actually measure how much power we have in total? So we have this much amount of voltage and this much amount of current. Is there any way to actually measure how much total energy we have between one and the other? Of course, there is a way to measure it. That's why we call it watts. Watts. An electrical device, the power measure of an electrical device, we measure it in watts. If it was a mechanical device, it would be horsepower. In this case, it's watts. What is watts? Watts is the product between the voltage and the current. One more time. If we're having a charge, a particle charged here, that it's not moving anywhere in any conductor. It can be air, it can be copper, it can be whatever you want, gold, silver, whatever you want. If it's not going anywhere, if it's not moving from point A to point B, your machine will not compute any work. The particles are not interacting with the rest of the environment. You need to have this particle moving from point A to point B. Now you're creating a circuit. Now you're creating an electrical device. The flow of this charge from point A to point B, we call it current, or simply we measure it in amps. So can you have a machine that works only on voltage and no current? No, again, it's bullshit. So the total amount of power, the total amount of energy this machine can compute, can the real work you actually have, the real potential, It's measuring watts in an electrical circuit. So this is really how much energy you're creating. This is exactly how much energy you're creating. Watts. It doesn't matter. You have a lot of current and no voltage. We don't care about it. It doesn't really matter. You have so much voltage. You can have 3 million volts, 65 million volts. If this charge is not moving anywhere, your machine will never work. You know, if you haven't created a circuit, electrical circuit. You don't have an electrical circuit if these electrons are not moving anywhere. I hope it's clear in the explanation. Let's go step to the next point. A free energy device, beautiful. So let's say I have a device such as this one, a hook, that allows me to actually steal energy from my neighbor's main line by hooking up some cables to it. Well, I end up not paying for my energy bill. Is this a free energy device, for instance? No, it's not. Of course it's not. So what is a free energy device then? So a free energy device must be a perpetual motion machine, first and foremost. So what is the characteristic of a perpetual motion machine? A perpetual motion machine has no input and has no output. A perpetual motion machine, it can be an optical machine, for instance, an electrical machine, a mechanical device, it can be a chemical device. Yeah. So the characteristic of a perpetual motion machine, first of all, it runs undetermined, like no time. This machine will run forever until you stop the machine. But mostly, a perpetual motion machine has no energy loss. What does that mean? It means that anytime you try to convert the energy from one form to another, you don't have an energy loss. If we have to pick a point, any point, in our perpetual motion machine, this one, this one, this one, this one, they will all have the same value. In this case, you are not creating energy, you are not destroying energy. You are just converting the energy from one form to the other with an efficiency of 100% or 1-to-1. So, is this machine possible to build? No, it's not for now. A perpetual motion machine is capable of self-feeding. So if you have one point who's actually producing energy, to the other side you're burning the energy. At the same time, you're capable of self-feeding again this machine with the same amount of energy. Of course, does not even make sense by talking about it. To build it, it's kind of even more complicated. So now, if you have to build a perpetual motion machine, that for instance it's a mechanical device, it takes a handful of minutes to realize that the machine will not work forever. It will stop suddenly. Probably won't even start, because it's easy to visualize a mechanical machine. Like, you can take a consideration like a clock that will run forever once you start spinning it. No, this clock will not run forever. It's a mechanical device, and it's easy to spot the problem here. Same for a chemical. Chemical reaction will not last forever. It can last for a while, but it does not last forever. It's easy to visualize it. So why does everyone is trying to build an electrical device? Well, electrical device is the easiest way to fool yourself and fool other people eventually on YouTube, convincing that you're a step closer to have that perpetual motion machine. Because you don't see the energy loss. It's not easy to see an energy loss into an electrical device. How do we measure how much energy loss we get? Actually, how do we know how efficient is our machine? To calculate the efficiency of a machine, it's actually very easy. You just take the total amount of power and you remove the energy loss you have once you convert the energy. And that's your efficiency. The efficiency of your machine, one more time, is the total amount of power, of energy, minus the energy loss. That's your efficiency. If you want a clever example of efficiency, a solar panel, for instance, it's only 18% efficient. 18%, 1/8, very, very low, very, very inefficient system for now. So we also have to highlight that any machine you want to take, no matter if it's an optical device, no matter if it's an electrical device, no matter if it's a mechanical or chemical device or whatever you want, they all respond to the fundamental laws of physics. They all share the same fundamental laws of physics. So now you're wondering, what is an energy loss? So where does all so much energy goes to burn? Where all this energy is getting lost to? Yeah, this is going to be the next point. Man, I like to spin this thing. Can you hear that? Yeah, that comes from my bearing. I only have one bearing over here. No, it's not broken. It's actually brand new. Yeah, the bearings, in this case, they're meant to reduce what we call a friction. Yeah, you cannot really eliminate the friction 100%, but you can slightly reduce it. Yeah, and for instance, your machine, if you're trying to build like a free energy machine, it should be completely noiseless. That shows us that you have no friction whatsoever, like zero friction. This is actually one of the most common energy loss we have in any system, no matter if you're trying to build an electrical device, a mechanical device. It's called friction. So what is friction? Friction is when you force some kinetic energy between two particles. That's what's called friction. This is friction. And you release heat. The friction between two particles suddenly generates heat. Yeah, and this amount of heat can be very small, maybe not visible, but it's there. Yep. So your machine needs to overcome this problem, this energy loss. I'll tell you more. We have two kinds of different friction. If you're having a moving mass, such a wheel, a flywheel, whatever you want to call it, we have two kinds of friction. The first one is called static friction. Static friction. The second one is called dynamic friction, or simple friction. So, what is static friction? Static friction, it's the energy loss. It's the kind of force that your machine needs to overcome when stand in still position. So your machine is not moving. Stand still. And you need to start that machine. That requires more force. So you need more energy input. In this case, it's an electrical machine, so perhaps we need more watts. As soon as you flip the switch on, your machine will draw more amps. More current, oh, of course, guys, just for a brief amount of time, but that's considered an energy loss. When the machine gets up and running, we stop with the static friction, we have actually dynamic friction or simply friction. So the dynamic frictions is the energy that your machine needs to constantly give to your wheel to keep up into this momentum. Let's make a little graph here. Maybe it's more. Let's visualize it. So, in this case, we're having an electrical. Try to build a free energy device with electricity, so it's an electrical device. The first step is to flip the switch on. So your machine will overdraw some amps, more current than usual, because we need to overcome the static friction. So we'll have a spike of current. When your machine settles at a speed, that suddenly you need a constant current to keep this machine up and running. Then, because otherwise your machine will start slowing down. This one is the dynamic friction. We call it dynamic friction or simply friction. This is another most common form of energy loss. When you try to build a free energy generator, you need to take it in consideration. Unless your machine you're trying to build, it's sealed in a perfect vacuum, you suddenly end up with another energy loss. This energy loss is called air. Air, it's a mixture of gas, including neon, helium, oxygen, but mostly nitrogen. Nitrogen makes up between 70 and 80% of air we breathe every day. And this is if the air is clean. It can get heavier than that. Air, it weighs about 37 grams per cubic foot. 1 cubic foot of air, it weighs about 37 grams. That is quite a lot. That creates a form of resistance against your spinning machine, in this case a spinning machine. That's what we call a drag coefficient. Drag coefficient. Yes, if you try to build an airplane, if you try to build any flying device, you need to take this in consideration as a first energy loss. Your machine needs to overcome this problem because your machine it's working and it's spinning in this case in a mixture of gas, a very heavy gas. It is called air. Now, we need to take in consideration this spinning mass. Anytime this spinning mass gets faster and faster, you actually suddenly end up moving more air. So the drag coefficient goes up. Yes, unfortunately it does. So you need quite a lot of speed. S stands for speed. But wait a second, you also need a lot of torque. I can tell you that. You need a lot of torque to keep this machine at its momentum. Otherwise, it will start slowing down. The torque required is proportional to the square of the speed. Yes, the torque required is proportional to the square of your speed. So the more speed, the more air you move, the more torque you need. But that's not the end. You also need quite a lot of horsepower. You also need a lot of power. And the power required to keep this machine and its momentum spinning is proportional to the cube of your torque. To the cube of your torque. Right there. So, on top of your machine is spinning super fast, the faster it spins, the more torque you need to keep this machine at its momentum. And I tell you more, the heavier the mass, the more it takes, the more energy it takes to spin. The power required, one more time, it's proportional to the cube of your torque. Yeah, that is quite of a lot of energy loss. A lot of energy loss that needs to be taken in consideration when you try to make a free energy device. Yes. I keep spinning this machine, but guess what? It keeps stopping for some reason. It comes to a stop for some reason. Yes, we have to take into consideration another energy loss. I know, you wish I was done, but now there is another energy loss that everyone should take in consideration when you try to make a free energy device. It's called gravity. Oh yes. Gravity, it's a force that pushes all the object to the center of the earth. Yes, even if you don't believe in a spherical earth and you're suddenly like a flat earth believer, you still have to admit that there is a force that pushes everything downwards. of course, no matter if the earth is flat, round, something pushes all the object downwards. Yes, and we need to take that in consideration. So in this case, we have a free energy generator that has a bunch of magnets or a bunch of coils, it depends from your configuration, but with an invisible force that is called gravity that pushes your free energy generator downwards. Yeah, even if you twist it upside down, the result will be the same, yes. So, this is another force that suddenly will stop your machine, yes. You need to overcome this problem, oh yes. The force that pushes against your wheel, that pushes against your axle, that pushes against your bearing, that will make suddenly this machine come to a stop, yes. The force of gravity pushes on an object is directly proportional to the weight of your object. Yes, it's a form of energy lost, an invisible form of energy lost that you need to take in consideration when you make your free energy device. Oh man, it's been taking all my energy. Too much resistance here. Too much resistance? Energy? What? Yeah, too much resistance. If you're trying to build a machine with zero energy loss, well, take in consideration we also have resistance, something called resistance, yes. If you're trying to push your potential down your conductor, suddenly we're having a problem. As we said before, it's not easy to modify the structure of an atom. So anytime we're having an electron leaping to the next neighbor atom, we have something called heat. Heat. Resistance in a cable produces heat. This is a form of energy loss. Yes, no matter how small is the resistance, but it's there, it's present. It does not exist a perfect conductor. Even a small piece of cable, if you try to make an electrical device and for instance you have cables, yeah, cables, copper cables, whatever cables you want, we suddenly have some resistance. Even like a small piece of copper cable about 3 inches can still give you enough resistance to drop your efficiency. Yes, drastically. Let's go take a look at these simple experiments to prove that we have enough resistance in a piece of cable. If anyone is considering to make a free energy device with zero loss in the system, well, using electrical cables is not definitely an option. Yeah, unfortunately, it does not exist a perfect conductor, and this is the proof. This is not a dash short, but rather a resistance. 300 milliamps, 200 milliamps we're having on this piece of cable here. And for as low as it sounds like, it's still an energy loss in your system. So, yeah. That was cool, wasn't it? You thought that a straight piece of cable was actually a dead short. No, it's not, guys. It's a form of a load. That's a load. It does not exist a perfect conductor. Every single conductor has some form of resistance inside. For as small as big, no matter. You need to take it in consideration when you try to make your free energy device. Here we're having a battery. Yes. We attach a piece of cable and you think that's a dead short. No, it's not. It's actually already creating a circuit here. This piece of cable right here, copper cable, it's actually a load. Yeah, this is a form of resistance. You already have a resistor right here, just by having a piece of copper, a piece of conductor. That is amazing, isn't it? Not everybody knew about this thing. I see a lot of people trying to build free energy devices, electrical devices, but not taking in consideration the wiring. Yes, that's a form of a load. That's a resistance. That's an energy loss. That's how we call it. And we have a simple formula here. This is not a law. This is an equation to calculate your resistance. And it's given, not randomly, by your potential, in this case volts, divided by your current. Simple as that, isn't it? Yeah, as I said before, this is not a law, this is an equation. This is a discovery, this is not an invention. If you try to build your free energy device without taking in consideration all the energy loss you have in your wiring system and harness, well, guess what? Your machine will never work. Energy loss. Another common form of energy loss is heat. Yes, heat. So where does this heat come from? Well, as we described before, in order to create a form of electricity, you need to have particles moving from point A to point B of a conductor. Having a negatively charged particle that we call volts that does not travel through your conductor from point A to point B, you haven't created any form of a circuit. You haven't created any form of electrical machine. Your voltage is useless. The flow of electrons coming from point B, from point A going to point B, we call it current. And we measure in amps. So anytime these particles, they move from point A to point B, this form of kinetic energy, it gives origin to heat. We are having heat. Yes, this is what described from physics as a thermodynamic. Thermodynamic. Dynamic, it's kinetic energy. Thermo, it's heat. This is something that you cannot quickly see because the energy loss, it can be very small, but it's still present and needs to be taken in consideration. This is one of the first reasons why perpetual motion machine will never work. If you're having an electric heater, this is the most common way to visualize this effect. Using electricity to create a form of heat, it's called the Joule effect. This is another common way of losing energy in your system. So another statement, another comment that I had a chance to actually read on one of the other YouTube channels is someone is trying to create a free energy device, an electrical device, by using high frequency, extremely high frequency, high voltage, and no current, very little current. Okay, we already proved before that there is no voltage if there is no current. I mean, you can have all the voltage you want, it's going to be pretty much useless. Another statement is that I have a high voltage, high frequency, perhaps my machine has no energy loss. Well, guess what? That's another big bullshit. Today we'll see why. Okay, high frequency versus low frequency. Obviously, you can tell this one it's definitely high frequency because if we take a period of our wave, it's definitely much, much shorter than this one. This is lower frequency. Now, this is our equation. This is the total amount of power, input power. This is our amplitude, what we call the amplitude voltage. This is the current needed to run this amp, to run this voltage, as we said before. It is true, the high frequency waves carries more energy. I'll say one more time. It is true, the high frequency waves carries more energy because particles are moving faster. And as we said before, there is more kinetic energy. That equals more energy in general. However, there is no way we're going to break the fundamental laws of physics, and this is one of the most elementary one. So there is a problem here. is that first of all, if you want to create particles, a system with particles moving faster, the switching mechanism requires more energy. Yes, guys. If you try to create a device, a high-frequency device, you have more energy loss in the system. First of all, because it requires more energy input. Should I say it one more time? If you try to create a high-frequency device, no matter what kind of device, it requires more energy. It requires more energy. Yes, more energy input. Second problem. It is true that we're carrying more energy in our high-frequency device, high-frequency waves. The problem is that we receive more attenuation. Yes, our amplitude, it will drop. Yes. Why is dropping this voltage? Because there is no way we're going to break the fundamental laws of physics. The total amount of energy should remain the same. For the principle of conservation of energy. Yes, we're not going to discuss about that one. I'm pretty sure it's going to be too complicated for someone out there. Yeah. Having a high-frequency device requires, first of all, more energy input. And the second problem is that high-frequency waves drops their amplitude drastically. And that's why in a high-frequency device, often we need amplifiers. We need to amplify the signal. Oh, yes, guys. Oh, yes. It does not really matter if this is a light form of energy. It does not really matter if this is a current, voltage, or whatever you want. We receive an attenuation. So our voltage will drop. Or we call it amplitude will drop. And this is a reason why anytime you try to make a high-frequency device, you need to keep your connection as short as possible. Oh yes, guys. If you try to build just like, not an extremely high frequency, but like a radio, like, you know, like a simple transmitter, even without modulation, the first thing you have to keep in mind, remember this, keep your connection as short as possible. We're talking about millimeters here. We are talking about 40, 60, 7 layers PCB boards in order to contain the whole circuit. Well, someone is out there trying to make a free energy device with a spark gap. With a spark gap, a washing machine motor, and a cheap knockoff eBay controller with long wires from the controller to the motor. That's not all. This guy is claiming free energy. Good luck with that. Speaking about EMF, an electromagnetic field. So the claim is, you know, see another video, of course, someone has tried to make a free energy again with high frequency, high voltage, and blah, 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 without considering the fundamental laws of physics. It's the EMF topic. So you use EMF, you don't need current, you don't need anything. The EMF will travel forever. Once you create an electromagnetic field, wow, everyone is free to use that machine, isn't it? No, you're completely wrong. You have a big energy loss here, like a huge energy loss when you try to use an electromagnetic field, simply EMF. Now today we'll see why. So here is what everybody likes, a Tesla coil that it's no more than an antenna, very low efficiency antenna, by the way. And this is our modern antenna, still analog antenna. Digital antenna is slightly different, but the concept is pretty much the same. So we're talking about EMF. So we're having this Tesla coil with a, let's say, 10 watts input to run it. Yeah. if a bunch of devices run at the same frequency around our Tesla coil, and every device it sucks 1 watt of energy, no, you're not going to have 10 devices attached to this Tesla coil. You're going to be much, much less than that. Much, much less than 10 devices. And you're like, oh, there is like an energy loss. Yes, there is an energy loss. There is no way that with a single Tesla coil you can add all the devices you want, and, you know, as long as they have the right frequency, the resonance frequency. No, guys. No, there is an attenuation here. Yes. It's not, no matter if hair or copper or gold or whatever is your conductor, it is still an attenuation. So EMF, they don't run an infinity length, you know, they run forever. No, they will not. There is still an attenuation. It's also a big attenuation. Yes, the Tesla coil will not run all the devices you want as long as they have the right resonance frequency. No, because the input energy is still 10 watts. The output is going to be less than that, not even close to 10 watts. Because if you have 10 watts, you can sum up all the devices and run your Tesla coil forever. No, that will never happen. You can try millions of times. It will not happen. An antenna, a Tesla coil or a modern antenna are very, very, very low efficiency devices. Yes. And I tell you what, there is another equation for it. Yes. If you want to know how much attenuation you get out of your EMF, it's simple. The attenuation, it's equal to the square of your distance. Yeah, that's a lot of attenuation. So if you pick a point nearby your Tesla coil or your antenna, the energy loss, the attenuation, the voltage, whatever you want to call it, the amplitude of your signal will receive an attenuation that is proportional, okay, to the distance, to the square of your distance. Yes, that will drop dramatically. You need some kind of amplification system that requires another energy input. Oh yes, a Tesla coil, it's not a miraculous device. It's actually rather a low efficiency device. There is no free energy here, guys. You wish it was, huh? Yeah. A modern antenna is slightly more efficient than an old Tesla coil. Yes, take your Tesla coil. Nowadays we have our antennas. But guess what? There is no free energy in EMF. Not at all. Rather quite a lot of attenuation and a lot of energy loss. A lot of energy loss. Let me say one more time. A lot of energy loss. One more time again. A lot of energy loss. A lot of energy loss. Magnets, they're so fascinating, magnets. Since you're a kid, you play with magnets. You know, I used to do it, so actually I'm still playing with magnets. They're so fascinating. You know, when you're a kid, you have so many questions about magnets, yeah, and their behavior. Guess what? Nowadays, we have a lot of equations describing magnetism and their behavior, like a lot of equations. You know, someone should definitely go check it out. Anytime you try to build a free energy device or simple generator, you can calculate it with extremely precision. The energy you're going to produce and the energy you're going to lose into your system. It's just that most of these people out there, they like to play and build devices without any mathematical calculation. They hope they will find something. They hope their device will work. Yeah, good luck with that. First thing first, a magnet does not produce a magnetic field. One more time, a magnet, it does not produce any magnetic field. The magnetic field is produced only once. When the magnet is produced, when the magnet is made, it's built, you create a permanent magnetic field. Like a permanent magnetic field, it means that nothing is moving. Your particles are not moving. No. Particles are not moving. If our magnetic field does not interact with the rest of the environment around and particles, this magnetic field is useless. I will say one more time. If this magnetic field does not interact with the rest of the environment and other particles, this magnetic field and magnet is useless. Yes. Second point, magnetism, it's not a force. I will repeat one more time. Magnetism, it's not a force. Magnetism, it becomes a force when a magnetic object interacts with our magnetic fields, feels like a force. The force is generated after a magnetic material interact with our magnetic field. Then you generate a force. This force is proportional to the strength of our magnetic field and the distance from the object. Of course, the closer you get to the magnetic field, the more force you receive. Should I say one more time? Magnetic field, it's not a force. Magnetic field, it becomes a force. When a magnetic object, of course something has to be magnetic, interact with our magnetic field, with our permanent magnetic field, then you're having a force. This force is directly proportional to the strength of our magnetic field and also the distance from our object. Yeah. So, if you try to build a free energy device, the more energy you want to produce, the more kinetic energy you need to imply to your system. Yes, it's directly proportional. There is no free lunch. We need to imagine our magnetic field, our permanent magnetic field, as a solid object. This is the behavior of our permanent magnetic field. You have to imagine our permanent magnetic field just like a bunch of springs here. A bunch of springs. Why is that? I'll show you why. Our spring, this is our compressed spring. In order to compress a spring, you need some force, apply some kinetic energy to it. Yeah. The amount of force that this spring is going to release once it's compressed is directly proportional to the force you apply to begin with. Yep. And I will say one more time. The amount of force this compressed spring is going to release is directly proportional to the amount of kinetic energy you used to compress it in the first place. Same for our permanent magnetic field. You need to imagine our permanent magnetic field just like a bunch of springs here. The more energy you receive by compressing our magnetic field, the more energy it takes to compress and interact with our magnetic field. Yep, it's directly proportional. So there is no free lunch. You want to have a stronger neodymium magnet, you want to have the strongest magnet on Earth, it takes probably more energy to interact with our magnetic field. Sure, we end up creating probably more energy, in this case an electrical circuit, but guess what? It takes just about more energy to interact with it. There's no free lunch. No, guys, there is no free lunch here. And if you try to make our free energy device with a bunch of magnets and coils, with a strong neodymium magnets, the stronger they are, the more force it takes to spin this machine. Yeah. Yes, more momentum, more torque, more horsepower, more speed. And you need to take them all in consideration. As one more time, there is no free lunch here. So guys, let me add a few notes to this video. I just want to say that even if you do manage to overcome all the energy loss into the system, that trust me, they're very big energy losses, you still have created something that can self-feed, some kind of perpetual motion machine. Not quite free energy yet. Free energy means that you're going to create more energy than the energy input you just used to run up that machine. Yes, where do you get the extra energy? Well, nobody knows. Only free energy claims knows about it, but yeah, it sounds like crazy already to say. Imagine actually to build such a machine. However, thank you guys for watching. That was a long video. Thank you guys for your patience. And for sure, I'll see you in another video of free energy claim.